K8s and vulnerabilities around it. Kfir, the stage is yours.
Thank you. Do you all hear me?
Yeah,
yes,
we can hear
very
you.
well.
Thank you. So today I will talk about how to actually to attack and mitigate a Kubernetes environment, mainly GKE in Google Cloud. And the thing is that it's a large area, so we will recap a POC, a singular POC. So let's start. Show the screen. Okay. So you all see, this is our webinar from Cilynx, the company I work with. The attacking and defending Kubernetes. And who am I? I'm a CyberOps consultant, as we talked about earlier. I'm experienced with a variety of consulting operations, from red team to web application, everything. And I actually stumbled across Kubernetes during a test at the start of my career. And I really became passionate about cloud, Dockers, and also the human factor. That's mainly what drives me in cybersecurity, and how the user and his experience comes in all of this story. Because as we know, Kubernetes changed the game of managing containers in an amazing way. So the agenda is quite short. Attacks in Kubernetes. I'll give a very short overview on Kubernetes and the attack surface, the POC, and then the takeaways and mitigations. Section 1. There are three different kinds of attackers: the external attacker, the internal attacker, and the privileged attacker. Those are the phases an attacker can take. Most of the cases, you will start as an external attacker, and you will stumble across a server that is exposed to the internet, and you stumble about, and he has like a file upload, unprotected file upload, and you get an RC or default credentials on the administration panel. Actually, this is the focal point I wanted to talk about in this presentation, but it became way too long, way above an hour and a half, on the issue with Nginx servers, and that they are given way too much privileges inside a cluster for not a really good reason, just to avoid issues along the way, errors, and things that will require some handling manually. And then after you get the shell, you are an internal attacker, but in a single pod, and hopefully for the organization with no real, without a real privileges. And the final phase, if the attack is successful, the attacker has privileges. And the thing is that in Kubernetes, they always say it's crunchy from the outside and soft from the inside, because it's hard to get in, but once you're in, the cluster is yours relatively easily. On the contrary of a domain on-premise in a Microsoft environment. This is a map of the attack surface an attacker can attack. As you can see, it's literally everything from the nodes, pods, control panel, the cloud environment, the cloud API. Really everything is vulnerable and reachable for the attacker if he gets the right credentials. So the attacker's methodology is fairly simple. And we start from the ground up, from the bottom. First, when the attacker needs a situational awareness about its surrounding. So it's checking the network. Could be ping, could be if config, could be anything. And then it will check for file permissions. Again, only to see if once he realizes that he's in a Kubernetes environment, there are very specific files and directories that he actually needs in order to move forward, to test for if he has root privileges, and of course the capabilities of the pod or host, and the privileges of the inside the cluster itself in order to escape the node from the node that runs the compromised pod. Sorry. So this is some Linux commands that are very useful, mainly the printenv, mount. They are really crucial to actually get either situational awareness or to move forward, and of course the ls for the directory of var run secrets Kubernetes. That's where all the tokens and certificates are being held. The third scenario we will talk about is a namespace escape and the privilege escalation. We will manage to deploy a pod in a root directory of a developer namespace node. And we will be able to deploy pods on any node of my choosing and gain the ability to create a schedule to deploy our pod in any node and gain access to any container. See, okay. We also have the cloud environment because it's on Google Cloud. We have the IAM, the storage, the metadata, and the metadata services. And again, the how to exploit instance in JKE metadata. So now it's the POC. Let's see that it works. Okay, so I'm starting with the kubectl. I'm trying. The scenario is as follows. In order to save time, I started, as you could say, from the middle. As an attacker, I managed to upload a web shell to a server. I got a hold of it, and I managed to gain access to the pod inside the namespace, and I discovered that the namespace belongs to developers, belong to development. And then I will try to deploy a pod here. And my odds are really good because developer usually needs the privileges to deploy a pod. So probably I could use it because that's the main way to continue the lateral movement inside the Kubernetes cluster by deploying pods. Okay, so as you can see, I'm trying to deploy a pod, but I can't. But if I use the flag of the namespace developers, yes, I can deploy a pod. That's great for me. So here I'm trying to here I have a typo, but I'm trying to deploy a pod, first pod. I won't be able because of the typo, but mainly what I'm trying to do is to deploy a pod that will never restart or close, that I will always have access to. And I'm asking for a description in a YAML file format, because mainly you will use YAML types inside Kubernetes. And then I'm editing it in order to fit my needs. And the thing is that if the cluster has a really adequate PSP configuration, then, and we'll go about it later, I won't be able to do much of anything. So here we can see the default configurations for the pod of Ubuntu. At that, I need to add several different stuff. Here I have one I prepared in advance because it's easier this way. So what I have here is I made a host IPC true, host network true, and one of the crucial stuff, it's the host, the volumes parameters. It's name host, but then host path and the path. My goal here is to deploy a pod on the root directory of the node that I'm right now inside it. Right now, I'm running in a contaminated pod, and I want to deploy a pod on the root directory of the node, because if I'm able to do it, I will have privileges on the node, the pod that I created. And because I have privileges on the root directory of the pod, I'll have privileges on the root directory of the node that hold the entire pods that I'm using right now. As you can see, there are also command, also bash is very important. The sleep, again, the mount path, it's for the root directory. And this is the main key. If I'm able to do it, then I will be able to escape. And it's a very small detail, and I know you think to yourself, who lives it, who run a cluster of Kubernetes without defining that you can do it. But as an consultant, I meet almost every day misconfigurations or default configurations that just insecure by design, as it's common in Kubernetes. It just happens. It's really irresponsible, since it's extremely easy to mitigate for this vulnerability, and I'll show you how. So now I'm trying to think what next. Yeah, I gave a pause for to explain. And then kubectl, and then I'm actually trying to deploy the pod, but here I can't do it because I don't have the flag for the namespace. Namespaces are extremely important. As you can see, it's not only for managing the cluster, it's also for limiting privileges for users. Here it's for an attacker. If I could deploy a pod on the default namespace or the system namespace, it will be even faster, a game over even faster. So here I'm adding the flag for namespace developers. And let's see if I can deploy it. Yes, I did, obviously. I deployed the Ubuntu iControl inside the root directory of the node. That's a really big step for me. Again, I started from this phase because all the recon beforehand, it's either very repetitive, and it's common when you get into any environment, not only Kubernetes, it's the same steps all the time. So that's why I skipped it. Let's see. And here, kubectl and developers. And now I'm checking that I deployed the pod. Yes, I have a pod, as you can see in the last one. Which means now I can access it and try to get to the root directory of the node. From there, I can do various things. I can take various actions, and then it's up to me and the mitigations that the cluster has. Now I'm inside the pod that I deployed. By the way, does anybody have any questions still now? I just don't see. No? Okay. So now I'm going to the root directory, my root directory. But since it's synced with the root directory of the node, I will be able to, here I'm writing that I'm on the host file directory. Now I'm able to do a chroot for the host root directory and use bash. Now I'm actually on the node. In a real environment, this node could hold tens of pods, even more, depending on the organization. And this is very crucial because right now I have access to each one of them instead of just the compromised pod I had and the deployed pod. Now I'm going to try to see all the, to access the Docker itself that runs everything, actually. Now I can see all the containers that are inside the node. And actually what those are all the containers that run in the environment. So I can just take one of them, one name, and since I have root privileges on the node, I can access each one of them, and that's what I'm going to do. see. Now I need to find one that I like. Yeah, so now I'm doing a Docker flag IT. I'm going to exec into a Docker that I chose. I forgot the sh at the end. Now I'm inside the Docker. It's a completely different environment since the one I started in, the different pod, excuse me. And now I actually escaped from the node itself. Now I'm on the Docker that runs the node. So now I'm trying to find what commands I can use. I can't use args or ps, but here I'm writing. We are in the namespace itself. Now I'm doing print in env to see all the containers that run in the environment itself, which I didn't have privileges to see before. I can actually see each pod, node, service, system names, everything. So that's also a really big step for an attacker. This is a successful escape. I could move forward here, but again, it will be quite repetitive since it will be the same commands over and over again. I will go to a different, I will search for a different node that I have privilege on, and then I will start the same process again. Right now I have access to other nodes, not the system node, also not the default I have for testing. They share same privileges, but right now I can move from this node that I escaped from, the developer, the node that inside the developer namespace, and I can move to other nodes and do the same process to try to create a YAML description of Ubuntu, try to deploy it in a root directory, and then from there continue to search for tokens, certificates, even I'll try to search for sensitive files. There was a scenario where in the cluster there was AWS keys, sensitive files, other passwords for other platforms, a lot of things in clear text. So moving, continue the lateral movement and pivoting, it's the main key. And now it's the main key to gain control over the cluster. And now I'm actually searching for the kubelet config files. Actually, this way you can use the config file without kubectl, without other tools that may raise alerts at the organization. Again, in this scenario, there are no different defensive application tools or things like this, but usually you won't start with kubectl right away, because all the products are heavily monitoring kubectl. So you will usually use curl or wget if you're in a different environment. And there are several tools in GitHub that you can use as a way to make your life easier with curl when you need several requests to send repeatedly, like options, then header post, all those stuff. And they handle it for you. So now I'm actually using the kubelet config file in order to use kubectl, which I can't use without it right now. I'm using it. If I won't use it, I just get an error that the system doesn't know the kubectl parameter. So now I'm using get pods. I can see all the pods under the node. Now I'll see also the system pods and the default namespace. I actually can see everything right now. I have access to see, and I have access to other nodes. As you can see, I can list 2 other nodes apart from the one that I'm at, since I escaped from the node itself. And here I have the IP addresses, external IP, OS images, really everything that I need to in order to have a recon and continue the lateral movement. Are there any questions right now? No? Okay. Oops, my bad. Sorry. Okay. So now there are also several images of like Ubuntu images that you can use that are like a mini security tools helper. Usually when you get inside a cluster, you won't have tools that you need in order to work and to do like PT, penetration testing for the cluster. So you will bring other pods by using their description. You will import, but right now I'm trying to access other nodes. Sorry, I jumped them. Right now I'm editing the description of the Ubuntu pod I just used in order to add another node name in order to deploy it in a different node. Yeah, I used this node name, one of the 3 we saw. Let's see. Let's see if I manage to deploy it. Oops, I'm sorry. Now this is the part I jumped to earlier. Now I'm trying to use a pod that I deployed inside the cluster. This pod contains several tools that actually help. The attacker could use them like Nmap and such. and a PT could use them as well. Right now, I'm going for the second. Since we don't have time, then I'll recap the first phase. I escaped the node, the namespace, and I had access to every container on the cluster, as you could see. And now I'm actually going to attack the cloud itself. I'm going to gain information from the cloud itself. Like here I have the IP of the API server. If you do ping to Kubernetes, it will give you the IP of the API server, the master node. And then I'm doing some nmap. Are we okay on time? Just to see if I need to fast forward.
I reckon we've probably got another 5 minutes, maybe. Is that right?
Oh, okay. Then I'll move forward. Sorry about that. So here I did the nmap, and it didn't give any results because my API server didn't respond. But now I'm actually going to query the Google Cloud, the JKE repositories in order to gain some more information. See, wait. So I'll fast forward. I'm sorry about that. So we have here the here we have this curl request. This HTTP request is for the metadata of Google compute me data. It's actually the information of my Google Cloud. Each company will have its own. It's not accessible from the outside, only if you have privileges inside the Google Cloud. And since I was able to escape from the namespace and the node, I also have privileges to do those queries. So I'm actually searching for instances in order to gain different. I'm actually now searching for the token, as you can see. The token that will actually, with this token, you can access the Google Cloud environment with the permissions, with high privileges. And then actually you can do whatever you want. You can gain access to images, files, other passwords, other users. Oops, here I forgot. Yeah. Slash. Here we have, now I'm going for defaults. And here, wait, I'll fast forward. Here we have the scope. Here you can actually see the what you can do almost everything you want here. But as an attacker, what I'm interested in is the dev storage read-only, obviously. And in order to access it, we will actually need a token. Now, usually you can just make an HTTP request to the token, but then I will expose my token for my cloud environment. So I'm putting it inside a variable to use later. So now I have an access token, and if this cloud had, say, a repository, I will I would use this HTTP request, this curl request, in order to gain images of the cluster. Here you can see. I'm going forward. I'm just trying to. Here we can see curl for the auth. Here I'm using the auth access token in order to gain access to the catalog of the images. Just a sec. So sorry about that. I'll recap. I'm sorry about the fast forward again. I'll recap what we had here. So this is the read only. This is the JS util. You can see. Sorry, I just got out of sync. You can see the list of resources available. Here you can, we got the token, access the container registry, and got the list of repos. This is the attack metrics that Microsoft published about Kubernetes. Those are all the phases and of attacks, impacts, everything. I do recommend going over it if you're using Kubernetes. And now I'll go over the mitigations. Mainly the big mitigation, as we can see. Okay, the takeaways, as we know, an attacker can attack Kubernetes, gain high privileges inside it relatively quickly. Everybody need to implement security, which doesn't happen. You need to use namespaces, use RBAC and disable the previous one. Now I forgot its name. Sorry. For PSP is extremely important. The pod security policy actually can prevent any step of the way I just did. Limit or remove console access. It's less comfortable, but it is possible to let the cluster itself manage the pods, and then you don't need all of the CLI. Block external egress, require authentication for all external ports. Actually, you don't always need, Kubernetes don't require you for authentication for a lot of different functionalities and request ports, everything. So you can implement it by using PSP. Protect the API server, and separate and firewall the etcd cluster, because if someone gain access to the etcd, then the whole cluster is in a great peril. The etcd actually is what it contains all the data of the cluster, and if an attacker gain access to it, it's a game over for the organization. And again, deploy RBAC and disable ABAC. PCP, as I said, you can create a lot of restrictions. You can create restrictions for Cilynx, you can enable Cilynx using the PSP. You can which will make files inaccessible for different users on the pod, for instance, or for services. Even a service won't be able to access those files. Obviously, utilize secomp in order to define the which will restrict the calls a privileged user can make or an unprivileged user can make for different syscalls. Configure cgroups in Kubernetes is extremely important because you need to also manage resources, and cgroup inside Kubernetes actually will help to defend against different attacks, either from deploying, you can do a mass deployment, horizontally deployment of pods like happened in Telsa in the 2018, and the attackers used a crypto miner, unknown one, and deployed hundreds of pods inside the Tesla clusters, and it took them half a year to find it and mitigate it. In the meantime, the attackers mined a lot of cryptocurrency and used Tesla resources. With the C groups, once a process, a pod, everything reached a threshold, actually the pod will die instantly. It will get killed, and then it will get killed, and then you will actually, the attackers will lose their foothold. Obviously, you implement automated security, rotate encryption keys, static analyze YAMLs, like the YAML I deployed. There is no reason it will be inside the cluster. Network policy, layer filtering, and obviously there are great open source tools like ECTO, Graphics, Claire, and obviously CIS benchmarks. This is a PSP, a minimal PSP I created. It's really easy to deploy, to use. You just need to read documentation 2 hours, and you can help to protect your cluster greatly. Thank you for the talk.
Okay, fantastic. Thanks so much, Kfir.
Sorry, I rushed the last part.
No problem. I think you're going to send us over your slides so people can go through them afterwards. Okay, that'd be great. And maybe put your. I want to move on to the next session now from Michael. So if you maybe put your contact details in the chat, then people can email you questions if.
Great.
Questions, if that's okay.
Great. Thank you.
All right. Perfect. Thank you very much.
Thank you.